What's up, guys? Yeah, so in the midnight, we are solving this interesting probability question. This is not my first time I film this question, but maybe I think previous my video is not so good, so I want to make it. So yeah, hope you guys subscribe to my channel. So N passenger board on airplane with exactly N seats, and the first passenger has lost the tickets and picked the ticket randomly. But after that, the rest of passengers will take their own seats if they're still available and pick our seats randomly where their final seats occupied with a probability that N's people get his own seats. Okay, and yeah, so I hope you guys already know the question. So yeah, so basically the first person has lost his boarding pass. Okay, so it's like this is the seats. Okay, then this is the person, the number one, number two, number four, number three, number four, number five, six, seven, eight. So these are person. Right, so in the this guy is very stupid. He lost his boarding pass. So he will randomly choose one position. Okay. And the rest guy will try to sit his own position if there is no people sit. If there's people already sit that position, then you will randomly shift to other position. And you want to ask their final guy, right? N's guy, which the probability that this N's guy sit into their position. Okay, so this type of question is like in the common interview question. So so my strategy in this quantum interview or probability interview, I usually start from simple case. So my strategy is that you start from simple case unless you already know the answer. So you start from simple case and then you guess the pattern. And then number three is using your powerful tool, which is a mathematical induction. Mathematical induction is like the most powerful tool in the world. Even the very advanced mathematics using this technique. Okay, so N is one is trivial, right? The probability is just one because I mean the first guy can only have one seat. Okay, so N equals to 2 is very simple. You have 2 and 1 and 2. So this number one has probability half to see this one to see the position of the second one, right? So the answer will be probability is half. Okay, so let's solve number N equals to 3. It's just for fun. So if you have 3 positions and 1 and 2, okay, so we have the probability. So the probability of one seat in the position 1 will be 1/3. In this case, that number 2 will go to number 2, number 2 will go to number 3. Okay, so number 3 will go to number 3. So this is okay situation, which the number 3 is sitting in the correct position. So it's correct position. Okay, and the probability one sit in number 2 will also be 1/3. So in this case, that in this case that this guy go here. Okay, so now number 2 is bad, right? Number 2 has 2 choices. Okay, so if number 2 go to number 1, then number 3 can stay the correct position. Okay, so we want to ask the probability to sit in 1 is just 1 divided by 2. Okay. Okay, so there's also probability that 1 sit in 3. If 1 sit in 3, then there's no way for 3 go to its own position, right? So it's also 1/3, but in this case, there's no way to correct. Okay, so the probability is just this, and this. So this times is 1 divided by 3 plus 1 divided by 3 times 1 divided by half. Okay, so 1 divided by 3 plus 1 divided by 6, which is 3 divided by 6, which is half. Okay. So yeah, so this is very simple. So you can see, oh, the answer is half, right? N equals to 2 is half, 3 equals to half. Okay, so you need to use your mathematical induction. So conjecture, always half. So the probability of N sits in the correct position is half. Okay, so we need to do the induction proof. Okay, so let's consider N plus 1. Okay, so consider N plus 1 people. So we have 1, 2, 3. Yeah, so this is position. So this is a seat. And let's say this is N. And then we have the rest, which is N plus 1. And then we have 1, 2, 3, 4, 5, 6, up to up to n and plus 1. Okay. Okay, so now notice that okay, so let's calculate probability very easily. Actually, there's a very easy way to calculate probability. So the probability of n plus 1 c in n, how to compute it? So the number one can go anywhere, right? So okay, so the first case is number one going this. Okay, so this is 1 divided by n plus 1. In this case, that 2 will go to 2, 3 will go to 3, 4 will go to 4. So everything's good. Okay, fine. So this is the probability that the number one goes to its own position. Okay. So now you need to consider that the number one goes to the rest of position. For example, number one goes to here. Let's say number one goes to here. The number two will goes to is correct. Number three will goes to number four will go to number five will goes to is correct, right? But you can see that if number one goes to here, then this problem is exactly the same as you. So you don't need to care about this guy, right? You can just eliminate this guy. You can just eliminate this guy, right? Then this problem become the same as the you can just eliminate this guy, right? So this problem become like the number one can randomly sit in this position, except for the first one. Okay. So you can ask what is you can use your results, right? You can use these half results here. Now I can ask now this problem becomes smaller, right? Because I don't care about this guy, right? Wherever this guy sit, this can be already eliminated. Okay, so in the rest of the case, right, there's a minus 1 and plus 1. In this case, that we can use our correct results, our assumption, right? Because in the rest a minus 1 current, then I can ask what's the position. I only care about this m guy where they sit into half. So okay, so let me just turn up using this. So I can eliminate this. Okay, and I force this guy. To see it, right? Then this whole problem becomes smaller than n plus 1. Okay, so the probability of the last the probability of the last guy seen here will be using mathematical reduction, which is half. So I can just half here. Okay, so we can just do a simple calculation. It's 2n plus 1, 2 plus n minus 1, which is n plus 1, 2n plus 1, which is half. So 1 divided by 2. Okay, so that's it. So simply speaking is that if in this n minus 1, n plus 1 case, wherever one seated, the rest will go in their position, right? So this problem effectively becomes a smaller problem. Then you can use your mathematical induction to just ask what's n plus 1 guy goes to n plus 1. But in this case, there's no n plus 1 people. Effectively, there's no n plus 1 people. So you just choose half. You're just using your mathematical induction assumption, and you plug it in, and then you get an answer. Okay, so simply speaking, this question is just this still be equal identity. Just this. Okay, so this you can view this equation is the answer for this question. Okay, that's it. Hope you guys subscribe to my channel. If you want to see more probability of this question, you can click the link below.